2.38, looking at fractions. A fraction is a way to represent parts of a whole. A fraction is written as a over b, where that little dash is what we all call the fraction bar. Now, one thing is for certain, the denominator b cannot be equal to 0, because if that happens, that is an undefined value. You are not allowed to divide by 0. All right, fractions that have the same value are called equivalent fractions, and we use this concept to reduce fractions. So if we had a over b and you opted to multiply both the top and the bottom by c, that's going to be the exact same value. The numbers are just bigger. And in reverse, when we want to reduce, we find the common factor in both the top and the bottom. We cancel those out because that's technically a multiplication of 1, and we've reduced the fraction. So simplify a fraction, rewrite the numerator and denominator, show that the common factors, if needed, factor the numerator and denominator into prime numbers first. Those prime numbers are 2, 3, 5, 7, 11, numbers like that, where the only factors, where the two factors are different and they have to be itself and 1. So keep in mind, 1 is not a prime number. It has to be 1 and a different number. 2, simplify using the equivalent fraction property up above, where we're going to divide out the common factors, which makes it, like we said, c over c is a 1, and multiply any remaining factors. All right, next, fraction multiplication. Well, straightforward. You multiply the numerators, you multiply the denominators. If a, b, c, and d are numbers where b and d, because they're in the bottom, are not equal to 0, you simply multiply straight across. A times c is the numerator, b times d is the denominator. Next terminology, reciprocal. The reciprocal of a fraction is found by inverting, flipping the fraction, placing the numerator in the denominator and the denominator into the numerator. So an example, if I have a reciprocal that is of 2/3, then it will be 3/2. If I want the reciprocal of 4, technically it's 4 over 1, and I flip it to 1/4. Fraction division. You don't technically divide by fractions. Whatever fraction you're attempting to divide by, you change it to a multiplication, and you multiply it by the reciprocal of the second fraction. So first fraction stays the same. You multiply by the reciprocal of the second. So it kind of looks like this. Here's my a over b divided by c over d. Again, b and d are not zeros. That will be the same as keep the first fraction the same, flip the second fraction, change it to multiplication, multiply straight across. All right, example time. Find the numerator of the equivalent fraction with denominator 12. And we have 3 fractions here. Problem 1 and problem 2 are the same questions. I'm just going to do them 2 different ways. You choose the one you like. So again, we want to write an equivalent fraction. That means it has to be the same value as what's given, but we want 12 in the denominator. So for this first problem, you take the denominator of 3 and you divide it into the 12. That's a 4. This 4 has to be multiplied to both the top and the bottom. That's the c over c that we saw in the definition. So 2 times 4, 8. 3 times 4 is 12. 2/3 is equal to 8/12. They are the same value. All right, here we go. B. 6 is my denominator. Okay, take 6 and divide it into 12. That's a 2. 2 needs to be multiplied top and bottom to the 5, 6. So 5 times 2 is 10, 6 times 2 is 12. 5, 6 is equivalent to 10/12. 1/2, okay, take the denominator 2, divide it by 12, we get 6. Multiply top and bottom by 6. 1 times 6, 6, 2 times 6, 12. 6 over 12 is equivalent to 1 over 12. So whatever they want for the denominator, divide it by the existing denominator in the fraction, take that answer, multiply top and bottom. Now another way to do this is finding the factors. It's saying the same thing, just writing it differently. So here we have 9/10 and we want a denominator of 80. So we break the 80 down into 2 factors. Well, one of those factors has to be the 10. Okay, so where did the 8 come? 80 divided by 10, 8. So we're going to take that 8 and multiply it to both the top and the bottom. So 72 over 80. Same concept, just a different way to find the common factor. Instead of dividing, you rewrite it as multiplication. But to break it down, you're basically dividing. So 4 ninths with a denominator of 18. 18 has 9 and 2, so we have the 9. We need to multiply it by 2, top and bottom. So 8 over 18. 8 ninths, equivalent denominator 36. Well, 36 has the factor of 9, which means it's 9 and 4. That 4 gets multiplied top and bottom. 32 over 36. Whichever one you want. I'm going to be honest with you. This is the one. I like the top one the best, but a lot of authors like these common factor concepts, which is fine. All works out the same. Right in lowest terms, so here 3 over 6. We're going to break that down. We're going to find these common numbers that we're multiplying top and bottom by. 3, if you factor it down, is 3 times 1. There's my prime. 3 is prime. 6 breaks down to the prime factors 3 times 2. So there's your common factor, which is a value of 1. So we're really multiplying by 1, and you multiply by 1, nothing changes. So my answer is 1/2. Now, sometimes, number 4, you've got to probably do this twice if you don't see the really big factor that's shared. Because this number ends in 5 and 0, I know both the top and the bottom is divisible by 5. So 45 divided by 5 is 9. 60 divided by 5 is 12. So there's my common 5. So I'm, if you will, factoring or dividing it out so I can cancel that out to a 1. Well, 9 and 12, not in its simplest form. We have factors of 3 in both 9 and 12. 3 times 3, 3 times 4. One pair of 3 cancels out. We're left with 3/4. Now we're in its simplest form. If you would have saw that 5 times the 3, the two factors that we canceled, 15 was the common factor, then you could have went 15 and 3, 15 and 4, and had everything taken care of in one step. Okay, 5 and 6, all the reciprocals. So here we go. Flip the fraction, 2/3, 3/2. 1/6, 6 over 1, or just 6 is fine. Reciprocal of 8, think of 8 over 1, flip it, 1 over 8. Real interesting, reciprocal of 1, 1 over 1 is 1 over 1. That's the only number whose reciprocal is itself. A mixed fraction, you can't flip this yet. You have to change it to what we call an improper fraction. And you hopefully remember this rule is you take the denominator, you multiply it to the whole number, and add it to the top. And that's your new numerator. So it kind of looks like this. We go 6 times 4 is 24, plus 5, 29. There's my improper fraction. Okay, now we can flip it. 6 over 29. Reciprocal of 0 can't happen. 0 over 1, if I flip it, I put 0 in the denominator. That's an undefined value. All right, number 7, multiplying. Okay, like we said, multiplying straight across. 4 times 2 is 8. 9 times 5 is 45. 8, oh, we have a negative here. 1 negative, so my answer is going to be negative. So if you want to put equals a negative, 6 times 2 is 12. 7 times 5 is 35. Negative 12 over 35. Here we have 2 negatives being multiplied together, which means my answer is a positive. And wait a minute. Hold the phone. Holding the phone. Look at my first fraction here. That's an even number, that's an even number. We can take and divide a 2 as the common factor out. So if I divide 18 and 14 by 2, that reduces this fraction to lowest terms of 9 over 7. And also, you can do this diagonally. Because we're multiplying, you can think of everything on the top as 9 times 8 and 7 times 5. Both the 9 and the 15 are reducible by 3. So we could take out a 3 as a factor. So 9 divided by 3 is 3. 15 divided by 3 is 5. Now we're into our prime numbers. And 8's not a prime number, but there's no other even number to cancel with 8, so we'll multiply across. 3 times 8, 24. 7 times 5 is 35. Again, you already predetermined the signs. You put the sign in your answer and just ignore them. All right, number 10. Let's see, lowest terms. All right, we got two negatives, so a negative times a negative is a positive. You can change them both to positive, scratch them out, whatever you want to do. Whoop, wait a minute. Look at this diagonal here. Both even numbers, so I know I can divide at least a 2 out. So that will give me 10 divided by 2 is 5. 14 divided by 2 is 7. Okay, multiply straight across. 5 times 5 is 25. 7 times 3 is 21. There's my fraction. Number 11, negative times a negative, another positive. Sign's done. Well, here we go. 6 and 3 are both divisible by 3, so 6 divided by 3 is a 2. 3 divided by 3 is a 1. Nothing else, so 8 times 2 is 16. 1 times 7 is 7. There's my fraction in its lowest terms. Here comes our division now. All right, so here's what we want to do. Change the division to multiplication and flip the second fraction. Even if it's a negative, you just flip it. Just leave the sign alone. So positive times a negative, we're going to get a negative answer, so put equals a negative. I don't see any cancellations here, so 5 times 7, 35. 6 times 6 is 36. They were trying to fool us to see if we would cancel the 6's before we changed it to multiplication. You can only cancel once you have the multiplication symbol. All right, 13, same directions. Okay, division, flip the second fraction, change it to multiplication. Oh, we got lots of canceling we can do. Positive times a negative, we got a negative for an answer again, but 4 can go into 8 twice, and 4 can go into 4 once. 5 can go into 25 5 times, and 5 can go into 5 once. 2 times 1, 2. 5 times 1, 5. A negative 2/5. All right. Next, 17 over 81 divided by 98 over 51. Okay, flip that second fraction. All right, let's see if we have any cancellations we can do here. Let's see. Yes, this diagonal here. Now, how did I know that? It's not because they end in ones, but the divisibility check for 3 is if you add the digits together, which is a 6, and if 6 is divisible by 3, the 51 is divisible by 3. 8 plus 1 is 9. 9 is divisible by 3, so the whole thing is divisible by 3. So 51 divided by 3 is 17, and 81 divided by 3 is 27. And 17 does not go into 98, so multiply straight across. We're going to get 17 times 17, which I think is 289. And then calculator tells me 27 times 98, 2,646. Okay, number 15, division, flip it. Any cancellation potentials here? I see one. I'm really good with football scores. These are divisible by 7. Touchdowns are 7 points, you know. So 35 divided by 7 is 5. 63 divided by 7 is 9. Wait a minute. Even numbers here. So we can divide out a 2. So that's a 10 and a 33. And that looks like it's it. So we're going to have 50 over 33 times 9, 297. Okay, 60. Divide 9/5 divided by 54. Okay, 54 over 1. Flip it. 9/5 over 1 over 50. Oh, there's a cancellation here. 9 can go into 54. What is that? 6 times, and 9 can go into 9 once. Multiplying straight across, we get 1 over 30. 17, we're not allowed to flip a mixed fraction. Remember what we did earlier. Take the whole number, the denominator, times the whole number, add it to 2. So this is what we're thinking about in between our ears. So 3 times 16, I believe, is 48, plus 2 makes that a 50 over 3. We flip the second fraction, change it to multiplication, and 5 can divide into 5 once, 5 can divide into 50 10 times. So 1 times 3, 1 times 10, 3/10 is my final answer. 18. All right, more division here. Let's see. Flip the second fraction. Oh, lots of cancellations. 9 and 9 cancels. 5 goes into 10 twice. We're going to have a negative answer. So we're going to have a negative 2. 2 times 1, 1 times 1. Negative 2. Oh, negative divided by a negative. That'll be a positive. But let's flip this first and then give us our positive. Ignore the signs. Okay, 9s again can cancel. 1s, 5 goes into 25 5 times. 1 times 1 is 1. 5 times 1 is 5. 1/5 is my answer there. Okay, next. Number 20. Simplify the expression. This is one big, huge fraction. All right, now here's what we want to do. This is a trick I learned, when I was in college and when you're taking these wonderful education courses on how to do this. What I was taught to do is take my fraction bar and make it vertical, and who's ever on top goes to the left, and who's ever on the bottom goes to the right. And now what we want to do is copy the top and now simplify it, copy the bottom and simplify it. So here we're going to have 8 plus 5 will be 13. 22 minus 8, how about 14? Now, because it's multiplication, don't multiply it. Leave it alone. I'll show you why in just a second. Over here, 6 to the third power. Let's see, 6 times 6 is 36. 36 times 3 is 216. We subtract 190. Well, let's see, if you're thinking about this, this could be 200 and take out. That looks like it's 26 to me. All right, now put the top back on the top, 13 times 14. Put the bottom on the bottom. Oh, see why we didn't want to multiply that together? 13 goes into 26 twice. So we can reduce this to 14 over 2. We can reduce it one more time. 7 over 1, we get 7 for a final answer. 21. When you have plus or minuses, you cannot start to cancel. Think about the numerator is completely in parentheses and the denominator is completely in parentheses when there's plus or minuses. So you have to simplify the top. That's going to be a negative 1. We're going to simplify the bottom. 4 plus 10 is 14. Now that's my final answer. Don't try to cancel when there's pluses or minuses. Remember, multiplying and dividing are opposite operators of each other. That's the ones that cancel each other out. So because I have division, subtraction and addition will not allow me to cancel, for example, the 4 into the 8. All right, number 22. It is estimated that each guest at the party will eat 3/8 pounds of chocolates. How many guests can be served if you buy 15 pounds of chocolate? Okay, this is a division problem. All right, so we're going to take 15 and divide it by 3/8. No, we're not. We're going to flip that second fraction and change it to multiplication and say, wait a minute, 15 can be over 1. 3 goes into 15 5 times. 5 times 8 is 40. So 40 guests can be served with 15 pounds of chocolate. If I was there, that number of guests would probably be reduced rather a lot. All right, Rick purchased a bulk package of candy that weighs 6 pounds. He wants to sell the candy in little bags that hold 1/4 a pound. How many little bags of candy can he fill in the bulk package? Okay, take the 6 pounds, divide it by 1/4. No, not really. Change it to a multiplication of 4 over 1, which is 6 times 4 is 24. He can make 24 smaller bags for that to be sold. All right, now what I want to do, I'm going to grab my calculator here. So I need to find my calculator. There it is. Okay, it's over here on my other monitor, hidden. Okay, so I want to go back to some of these problems here. Okay, some of these really ugly problems. And I'm going to replay. I'm going to move in here first. Okay, rerun it. I want to show you how to use the fraction command on your calculator. All right, so remember, you want to grade this. So for example, let's say you want to check, let's even back the boat up even further. Let's go to our multiplication problems here. Let's pick a couple multiplying problems here. The one that had a lot, let's take number 9 here, for example. So let me make my calculator a little bit bigger so you can see everything I'm going to be doing. I'm going to clear the bottom here so you can see the buttons I'm pushing. All right, here we go. Now, to acquire a fraction, all right, we're going to type in the negative first. Now, for the fraction, it's the alpha button, then the y equals button. Then a little window pops up, and here's our icon, numerator over denominator. Just hit enter. So then we just type in the values. Get out of the denominator, then put in your times symbol. Then a negative. Put in your another fraction symbol, alpha y equals. Enter. 8 over 15. All right, so since you're using this fraction command, you hit enter, your calculator, it gave me a decimal. Don't panic. All right, just hit math, number 1. This command says return my previous answer as a fraction. So you can see ANS, that's the previous answer, changes it a fraction to 24 over 35. That's what we have. All right, now, however, special rules. I got to go through all these. Okay, let's get to the division problems. We'll look at our first one here. Now, special rules in typing this in. Not for this calculator. If you have that alpha y equals, type it in as a fraction. You get the text box over text box. Life is good, because then you can just hit the division symbol, type in the negative, not the minus sign. In fact, this is what I'm going to do. I'm going to type in a minus sign so you can see what the calculator is going to do. All right, for alpha y equals fraction, 6 over 7. I hit enter. It says syntax here. Never hit the quit button. Hit the go to. So press number 2. It will put the cursor on the symbol it doesn't like. Oh, that's the minus sign. Okay, change it to a negative. All right, now, with this fraction typed in, you saw last time we had a decimal, you can hit the math button and ask for it to return your answer as a fraction right away. And there's my negative 35 over 36. Now, some of you, if you don't have that world famous y or alpha y equals, you don't get this pop-up window. Okay, here's what we're going to do. Using this problem here, you have to type it in the following fashion. A fraction is technically a division problem. So unfortunately, you have more calculator typing to do. Each fraction has to be placed into parentheses, divided by. Second fraction has to be put into parentheses with the division symbol. You can still ask for the answer to be returned as a fraction, and it will still give you the fractional answer. Now, on those older calculators that don't have this ability to type the fraction in this way, they'll just have the answer look like this, negative 35 with a diagonal fraction bar, 36. That's the way your answer will look if you don't have the alpha y equals command. You can still do the fraction work, you just have to put the extra parentheses around all the fractions when you do the work. Okay?